All right. You're on.
Okay, good afternoon, everyone. Welcome to Front Row with the Faculty. My name is Joanne Bean. I'm the Vice President and Chief Advancement Officer here at St. Joseph's College. And it is my pleasure to bring today's subject matter, which is mathematics. If that has scared anyone in the past, I know I could raise my hand and say, yes, it still scares me today. We have a really interesting speaker who's going to talk to you about that, and I'll introduce Professor Mahoney in just a minute. First of all, let me just say that welcome. Glad to see some familiar faces. For those who I don't know, we really hope that you'll have an opportunity to engage not only in this, but in other events at the college. Our summer is very, very busy, so visit our website. We hope to see you on campus for all sorts of initiatives, programs, good food, and more. Beautiful day today, and we are going to have this program recorded. We do repurpose it and put it on our website, and there is an opportunity for questions and for you all to engage with the speaker. Right now, we're going to keep our microphones on mute, and towards the end of the conversation from Professor Mahoney, we're going to then open it up for questions. So you can do that by either typing in the chat or raising your hand. It's a small group, so feel free to do that. I have the opportunity of introducing Kevin, and if you give me a minute, my other computer here with his introduction just sort of froze, so hold on a second. And I am going to take you through a little bit about his background and also how excited we are to have him join the campus for lots of reasons that you're going to find out relative to what our students think about him. Just one second. Sorry for this. Okay, so Dr. Mahoney comes to us from a long career in elementary education. He's worked for 28 years in elementary schools, 15 years as an elementary school teacher, and 13 years as a curriculum coordinator and teacher coach for mathematics. He is taught in all grades, pre-kindergarten through 6th grade, both public and private schools. His early experiences in the classroom led him into a specialization in the teaching and learning of elementary mathematics. Dr. Mahoney consults with schools both nationally and internationally in their work with implementing mathematics curricula, and lots of interesting countries and places, but one country such as Singapore is what he's going to describe for us today, and their work in mathematics. In his spare time, he enjoys reading, camping, fishing, hiking, and art. And most recently, we're so proud of him at St. Joseph's College. He received and was named the recipient of Excellence in Teaching Award. This award recognizes a faculty member for outstanding achievements in their fields of study and whose commitments to teaching have made meaningful and significant impacts on the intellectual development of students. Characteristics such as enthusiasm, creativity, respectfulness, ability to prepare, and the opportunity to engage and impact students in learning are all used to select this recipient. It's a very prestigious award, and we are so proud of Kevin for receiving it this year. And without further ado, I take it on to Dr. Kevin Mahoney. He's going to talk to us about mathematics in Singapore. Kevin.
Thank you, Joanne. Thank you very much. Everyone can hear me and see me fine, I'm sure. Okay, great. So I'll start off talking about mathematics in Singapore with just telling a bit more of my own little story here, because it's a story about synchronicity, I would say. As you heard from Joanne, I was an elementary school teacher for years and years, and became a specialist in elementary mathematics, and was so probably about 15 years ago or so, I was in a professional development workshop, and maybe some of you know who've been through these kinds of things that they can be hit or miss, and this one was a miss. And I was not particularly attentive in this particular presentation, but a friend of mine slipped a textbook onto my lap. And this was a textbook that came directly from the country of Singapore. It was an elementary level textbook. And I looked at that and started to completely ignore the speaker and just dive into this textbook because it was so different from what I had seen before, became very interested in this. I went back and convinced the school that I was working for, to adopt these textbooks as our math curriculum. These were textbooks that were used directly in Singapore, but they were so engaging and so interesting that I thought they'd be very effective for our students. That led to even more interest in how mathematics, especially at the elementary level, is taught in Singapore. So I went back to school and earned a doctorate. I think I was the first American to earn a doctorate studying the effects of Singaporean pedagogy on students in the US. And I'll show you a little bit more about that as I talk. So that doctorate led to my position here. It led to consulting in schools all over the country. And just couple of years ago, I was able to go to India on a 5-city tour, training teachers in 5 cities in India. The idea of how math is taught in Singapore combined really well with my interests in teaching math well, but also the curriculum has spread all over the world. So if any school system is thinking about changing or upgrading their math curriculum, in many countries, not just here in the States, but certainly true here, then at this point, a textbook series or a curriculum that's influenced by Singapore's approach is going to be on the table. They may not choose that, they may not be what they like most, but Singaporean approach to teaching mathematics is spread all over the world. And that coincided very nicely with my interest in this program. And so it's something that I never seem to get tired of talking about. And I'm so glad to get an opportunity to talk about it here. So what I want to do today is talk with you. I want you to leave with an idea about what's different about how mathematics is taught in Singapore. And what I'm talking about is mostly deals with the elementary level. That's where the biggest differences are. And that's where the foundations are laid for Singapore. You see, Singapore, for about 25 years or so, has been recognized as performing at the highest possible level, #1 in the world in elementary mathematics performance. And that's been going on for about 25 years. That gets a lot of attention. And I want to explain why that is. I want you to see what this curriculum is like. And I want you to actually do some math with me together. I promise it won't be threatening. Okay, we'll hopefully it'll be fun. Hopefully, we'll keep our fingers crossed. Okay, so let me start off my slides. I think we'll start with my slides here, and I'll run through my slides and give you this overview, and then there'll be lots of time for questions, and we can discuss what's of interest to you here. Okay, so keep an eye on my time here. What I want to get to here is what the characteristics of this curriculum and what it really looks like, to give you a flavor for what it looks like in terms of the materials and the way that mathematics is taught. Okay, so I don't know, have any of you been to Singapore before? Anyone here? Yeah, I never have been. It's on my bucket list for sure. Considering all the amount of hours I spent talking about this topic, I should have been there already. But think of a tiny city-state, really. I mean, it is an island. There is more to it than just the city, but it really is like a city-state, and doesn't have a democratic form of government. But in the 80s and 90s, Singapore does something really interesting. The centralized government makes a decision, a really important decision that has ripple effects throughout the entire society. And this decision is really profound. They decide that the greatest natural resource for the nation of Singapore is the intellectual capacity of its children. The greatest natural resource that this tiny little country has is the intellectual capacity of their children. And from that idea, it spreads in lots of places throughout the government and society. it has an effect on how mathematics is taught. You see, because as part of this decision, they decide that the language of instruction in Singapore is going to be English. Even though there are 4 or 5 different major languages spoken and not one completely dominates over the other, everyone is going to go to school and be taught in English. So that means that in Singapore, they've got to think of a way to teach mathematics to young children that allows them to learn mathematics without a lot of written language. These are children who are learning English while they're learning math. So if you think about that for a second, how would you do that? How would you teach math to a child in English who was just learning English? Well, Singapore's approach, of course, maybe you thought of this as well, is to be very visual, to teach very visually. The Ministry of Education in Singapore develops all of the curriculum for the country, and they also train all of the teachers. So through this process, because it's centralized, teachers are trained, mathematics curricula is developed to meet these new goals. And what happens is that even before the 1990s, I like to say before the turn of the century, because it makes me feel so darn old. But before the turn of the century, Singapore's curriculum starts to really have its effect on its children. And the nation enters into these international comparison studies. One of the famous ones is the TIMSS study. Maybe you've heard of that. There are several others. And Singapore ranks #1 in the world in mathematics performance. And that happens every 4 years, very consistently, #1 in the world. It wasn't just one particular year. So because of this consistent performance, people all over the world want to know why. Hey, what is that? How could we bring some of that to our country, to our teaching? And of course, there are hundreds of reasons that deal with societal issues, cultural issues that have to do with why Singaporean kids perform so well in mathematics. I'm not going into those reasons, because I'm like a lot of researchers all over the world who wanted to know, well, okay, there are these cultural differences, there are cultural reasons why this happens, but what about how the math is taught? What about the textbooks? What about the teaching methodologies? There's got to be something there. And so this starts to happen, in the early 2000s, that textbooks from Singapore, because they're in English, they come over to the United States, to Great Britain, to India. They start to filter their way around the world. People are very curious. Gets a lot of international attention, these test results. So researchers around the world start to dig into Singapore's math. They talk with Singaporean educators, and these are things that are characteristics of the curriculum that have been proven through research, not just through simple observation, but really proven through research. So a big idea here is that in Singapore, students are taught using this concrete, pictorial, abstract approach to teaching. Typically in the US and lots of places in these times, a teacher who's going to teach a child a mathematical concept is going to bring out some concrete materials so the child can make a model of this abstraction of a mathematical concept. And from that concrete representation, slowly they move the child to an abstraction. Okay, here I know that this is very simplistic, but I'm modeling here 2 + 1. You see the green and the purple. That's a physical model. The child can manipulate these objects, take them apart, put them together. That's a concrete experience. And if you see 2 + 1 = 3, that's actually really quite abstract. So Singaporeans, in part because of their teaching conditions, they insert this bridge between the concrete and the abstract. They ask kids to draw pictures and diagrams. Now that's for very practical reasons, because of the visual nature of the teaching that they have to do. But this concrete, pictorial, abstract approach, well, that becomes characteristic. They teach visually as much as they possibly can. They also believe it pretty firmly and know that mathematics is learned best when students get multiple different representations of a math concept. Each one that a child has to wrap their mind around helps them develop the concept further. So if I'm teaching about fractions, remember learning about fractions when you were a kid probably, I want to show students fractions in lots of different ways and get them to wrestle with each of these different models to deepen their understanding of what's going on. In Singapore, there's a much bigger emphasis on solving problems, not sheets of not like worksheets of computation problems, but word problems. Some that have clear answers and some that don't. But problem solving is a big emphasis in the curriculum, and mental math is another big emphasis. Children not only learning those multiplication and addition tables, but learning learning strategies for calculating with these numbers in their heads. There's a bigger emphasis there in Singapore, and that's because this activity of mental math really builds a sense of number, builds a sense that for children that numbers are like Legos. They can be taken apart and put together again to do your bidding and make your work easier. This is something that is typically missing from typical US math education. And the last piece is an interesting argument, and I don't know if you're familiar with this, but in the States and in lots of other places, there's a debate about how math should be taught. The way that I was taught mathematics was with a very heavy emphasis on what's called procedural fluency. I wonder if this is true for you. I really do. I was taught in elementary mathematics classes to here's a procedure, here are the steps, follow the steps. Now that you've followed the steps, practice those steps over and over and over again until you become fast and efficient with those steps. And that is a way to learn mathematics. Much of our math education system is built upon this simple idea. Learn procedures, graduate from that procedure to the next procedure. When I was I'll tell you this quick little story. When I was in 6th grade, my 6th grade teacher was teaching us how to divide fractions. Do you remember how to do that? You had to take the two fractions as a division problem, and then you turn the problem into a multiplication problem and flipped the second fraction with the reciprocal. Do you remember that? Okay, so I was taught this little ditty. Ours is not to wonder why, just invert and multiply. And that captured a lot of that characterized a lot of my math education. Literally, my teacher was exhorting me, do not think. No thinking. Thinking's bad for you. Just practice the procedure, just memorize it. Now, for a kid like me, that was not enough. And I was not a strong math student. In fact, I developed quite a bit of anxiety around mathematics as I grew up. And it was learning mathematics in new and different ways that actually made me excited to teach math to children so that they would avoid the kind of teaching that I experienced. So that's teaching with procedural fluency, and that's pretty common in the United States. But another point of view says, those procedures are not that important. What's actually far more important is to understand conceptually how it works, is to understand how these components come together. And that understanding gives a child confidence and even curiosity that they could then apply to procedures and help them understand how these procedures work. I tell kids in my work, you in mathematics, you have to know, I'm going to teach you how to ride a bike, how to ride that mathematics bike, how to work through the procedures, but I'm also going to teach you how it works. The best mathematics students have both of those things. And Singapore's curriculum does this. They do that. They say they are attempting to achieve this balance, and by and large, they do. So that makes it. These are these characteristics that make it a little bit different from typical teaching in the United States. And I know I'm talking at you quite a lot here, but now I want to give you a little tour. okay, and show you some Singaporean textbooks. Here's a picture from first grade. Now, if you're familiar with American textbooks, what you see a lot of is a lot of decorative elements on pages that are supposed to engage and entice students. Not true in Singapore. Every graphical element and text element on the page is used by the mathematics teacher. Here, we're talking about multiplication and division in first grade. And we're seeing 3 groups of 5 apples. And then we're seeing this in text. And then we're seeing this again in what's called a mathematical array. Just to show you that they're talking about these multiple examples. Moving up just a grade or 2 in textbooks, here we're talking about the number 3,274. Now look how this is represented to kids. These little coins, they're called number discs. They're like little coins, and students will have these physically in their hands, and they will build on a little place value chart. 3,000s, there's the 3,000s, 200s, 7 10s, and 4 1s. Here it is represented in a different way, 3,274. And these cards that are stacked on top of each other and then expanded and contracted on top of each other. Do you see how these cards would lay on top of each other to display the number 3,274? Okay, think about it. This looks simple, but it's very powerful mathematically. And American teachers do use things like this. It's not completely foreign to them. It's just that we tend to fall back on the way we were taught and not utilize these strategies as much as possible. Here is another page. We're talking about now taking these numbers and adding them. You'll see we're adding 236 and 362. We're building them with these number discs so that the child can understand physically what's happening with the 1s, 10s, and 100s. And then they learn that old shortcut, what we call the standard algorithm. So you see this big emphasis on understanding how it works through physical models, and then learn those shortcuts and fast procedures with meaning. And this, again, this is not completely gone from the United States or in any way like that, but Singaporeans have come up with more visual approaches and effective approaches to help kids understand the math that they're supposed to be learning. Okay, so now I want to do some math with you. You've gotten a picture of what the textbooks look like. You see why people are talking about this curriculum in the United States. And now I want to do a problem with you. Okay, so I want you to get out a pencil or a pen and a piece of paper. And I really want you to try to solve this problem, okay? Because what I'm going to do is show you how kids in Singapore would be taught to solve this problem, okay? I don't care what you do to solve the problem. You could make a drawing. You could use algebra. You could get on your phone and call somebody. You could try to look up whatever you want to do. I just want you to engage with this problem. Old Front caught 435 mosquitoes and dragonflies altogether today. She caught 4 times more mosquitoes than dragonflies. How many more mosquitoes than dragonflies did she catch? So what I'm looking for from you is a solution, a numerical answer. If you don't have a way to find the exact answer, take a guess at what number it could be. Make an estimate, okay? All to make you think about these relationships and consider them. Now I'm going to be quiet for a little bit. Okay. If everyone could turn your camera on and give me a thumbs up if you've If you've gotten there, if you've gotten to some kind of solution, or thumbs in the middle or thumbs down. Where are you? I don't want to take too much time. Okay, good. Okay, so people have interacted with the problem. All right. So now what I want to show you is just one of the methodologies that Singaporeans have developed to help kids with this situation. Whether or not you solve the problem or not, I just want you to engage with it. You see, word problems are universally tough. It doesn't matter what country you're in. Word problems are really challenging because we're asking kids to change, to sort of convert text into mathematical concepts. We're asking children to read a text very carefully to pull out important information and leave behind unnecessary information. We're translating reading text into mathematics, and that is very challenging. There is a massive body of literature, in research literature, just on this idea of helping kids solve problems or word problems where they're applying mathematics to lifelike situations. Okay, so this is universal. So this technique became famous. It became well, famous is a relative term, but they, really well connected with Singaporean approaches to teaching math. Let me show you. I'll stop yapping and show you. Okay, so here's a sentence here that's going to help us focus on the answer. Bullfrog caught blank, more mosquitoes than dragonflies, and the child is taught to build what's called a bar model. It's a model. It's a drawing. There's that bridge between the concrete and the abstract. Make a diagram, just like maybe you've been asked to diagram sentences. Diagram this word problem, okay? And here's the amount of mosquitoes, and here's the amount of dragonflies. Right now, they're both equal, okay? The child draws another extra box here to show there's 2 times as many mosquitoes as dragonflies. Now there's 3 times as many. Now there's 4 times as many. We also know that altogether there are 435 bugs. Now just stop and think and look at this model that a child would have drawn. Could this help you? Did it help you understand the problem a little bit more? Even if you don't have an answer yet. Okay, let's dig a little further. The child's then going to be taught to draw in a question mark. A question mark that shows that child, this is what we're looking for in this problem. Don't get confused with all this information. This is what we're after. And if we're after how many more mosquitoes, that would be this amount here, this extra amount. That's what we're looking for our answer. Okay. Now there's a complete bar model. That's what a child, even in 2nd grade, would be taught to use as one of the possible methods for solving this problem. Okay, now maybe you've looked at this and you're starting to think about this mathematically. I can see, can you, that there are 4 equal boxes here and 1 more down here. So there's 5 equal boxes, and 5 of those boxes is 435. So the key to solving the problem is figuring out what's in one of these equal boxes. And using division, 435 divided by 5, we get 87. What's interesting is that in Singapore, children could choose to use like the standard long division algorithm. Maybe you remember that as a kid, or they might tackle this with mental arithmetic. There are lots of possibilities here. So they come up with this answer that 1 box is worth 87. Oh, and they'll often go in, children that I teach to do this will often go and write every 87 in there that they can, because it makes it crystal clear. We need to answer the problem. We need 3 of those 87s, and 3 of those 87s is 261. So bullfrog caught 261 more mosquitoes than dragonflies. Now, this is designed primarily to help children make sense of these complex word problems. Okay, they're drawing a diagram. That's really helpful. Very helpful to lots and lots of kids, learners who really struggle with language, learners who are more advanced and need to actually be able to use reasoning and communication to prove their thinking around a problem. So this is a very useful technique, but it also, by design, is teaching children algebraic reasoning at an early age. So this 5 boxes is 435 and 1 box is 87 and 3 boxes. That's algebraic reasoning. They don't call it algebra. They don't tell the children that they're working algebraically, but this is designed also to model and help children think algebraically at young ages. So that's a demonstration there of bar modeling in Singapore. Now I've got a child's version. I gave a child in my doctoral research, I gave children, but what my research was is I went to rural New Hampshire, that's where I am right now, and I got a bunch of subjects from the local school system. And they had never seen this technique before of bar modeling. And that was my research, was to teach them how to use this technique and then see how their performance changed over time. And this is right from that research. So here's a child, and they drew 4 boxes here and 5 boxes here. They did their mental math here, and they came up with their sentence was 261 more. That's the entire sentence. But I wanted to show you that real kids actually use this successfully. And the problem that you saw here with the mosquitoes and the dragonflies, that's typically a problem that you might see in 6th, 7th, 8th grade, sort of a middle school math problem. But when a child has this visual technique, they know it, they can use it as a tool. I can give this problem to 3rd graders or 4th graders. These kind of visual strategies, in fact, help students they learn more advanced content at younger ages in Singapore. And that's true in the United States too, of schools who start to use this kind of curriculum. Okay, so through the textbook examples, through my talking, through the demonstration I just did, I hope that you see these characteristics in what I showed you. This concrete pictorial abstract approach, multiple visual presentations and representations of numbers, this emphasis on problem solving and balancing conceptual understanding with procedural fluency, all those things together. So that's my, I hope I answered these questions in this nutshell of a presentation. What characterizes the curriculum and what it looks like in terms of materials and pedagogy. And now I just want to field questions from you and let's have a discussion. So what's on your minds, if anything, or did you fall asleep during that presentation?
That's great, Kevin.
I have a question.
Yeah, hi, Peggy.
Hi. So I was a math teacher for, I don't remember, I don't know, 12 years, 17 years, depending on how you characterize it. But I've taught, we didn't have Singapore math textbooks, but I still used some of the methods. And I just want to ask you, when you presented the problem, I solved it using what I think of as a Singapore math, but I want to ask you, I did my diagram a little bit differently. So I want to show it to you and ask you what you think. So I did,
I see.
I just did 1 with 5.
Yep.
And then, so my method, I ended up having an extra step because I divided by 5 to get 87, multiplied 80. So this is my extra step. I think it's backwards, right? Is it coming up?
Backwards, fine.
Yep. So I multiplied by 4 to figure out how many mosquitoes there were.
Yes.
Then I subtracted 187. I mean, I know it's valid, but is this like, as far as efficiency, it was fast for me because actually I solved the problem before you were done reading it.
Great.
Just to show how efficient this method is.
Yeah.
And I would tend to just have the kids then present their different methods and validate every method that was, accurate, and have them share. But I'm just curious, what do you think about this, about like teaching the kids? Like, I think this actually is the way I would have taught it.
Great.
What do you think about that with the 5 versus the 2 layers?
Great question. So glad you're willing to show your work and everything. Love it. I love it, Peggy. So absolutely. So you are using the same method that I am. You're just representing the mathematical relationship slightly differently than I am. And so what I would do in this situation is, just as you said, you have the answer yourself. I'd talk with students and say, well, whose model is right?
They're both right.
That they're both right. And I want both students to defend their thinking, defend their reasoning. We might have a discussion about efficiency later on, but really it's about who can communicate and reason, who can put forth their model in a reasonable way. So the way you model it, the way I model it, actually are both valid. And the way that I was modeling it was that I characterized that problem as a comparison situation.
Mm-hmm.
So that's why I was comparing these two pieces together. You characterized it as all these different parts of a whole. We can look at it either way. We can defend either way. And that's really actually empowering to kids, as you probably know.
Yeah. Okay. Okay. Thanks.
Love it. Absolutely love it. Who else has a question or a comment or a concern?
Well, I think I've been on the state, I've just got off the State Board of Education. I've been on for 14 years.
Oh, wow.
I also ran into some Singapore business people at a conference I was at a few years ago.
Hmm.
And they said, you know, we're very bright, but I wish we were more creative like the Americans. And it makes me think that they're somewhat mechanical in Singapore. And if you want to look at the country, you got 5 million people, and they're told you can't spit on the ground, you can't chew gum, you can't do this, you can't do that. You got a society that's very different than America, which is very diverse. But the businessmen long to have more creativity and less regiment. I'm very interested in what you're, you know, how you're depicting a simple math problem. But I think there's two sides of it. I think Singapore is number one because you've got a country with an average income of $54,000. You've got a very upper crust kind of thinking in that country. And it would, if you could take the best of America and shove it into 5 million people, then you'd have a different test result. By the way, Maine was number one in math and science back in the 90s at one time in America. And I guess Kate and I and somebody else were celebrating the fact we were number one in math and science. We've definitely gone backwards in the last bunch of years. We've been trying to get our hands around proficiency or standards and all that kind of stuff. We just keep debating and battling. I really think this is an interesting depiction of elementary math. Now, I don't know if it's a first grade, a third grade, or an eighth grade, but I think it's very interesting. So I appreciate that.
Thank you for those comments. My friends in Singapore tell me the same thing. As those business people that you would talk that they, there are many initiatives underway and have been there for a while to help students become more creative, to encourage that, because they are looking to us as models in that way. So, and it's very, very interesting if you go way back in the history of their curriculum. In the 90s, as they started to redevelop their math curriculum, they went all over the world to look at best practices. And one of the places they went was the United States. And they looked at the NCTM, the National Council of Teachers of Mathematics. They looked at those standards, brought those standards to Singapore, and then worked on them themselves and how we could get kids to really learn these. So it's math education is influenced by all kinds of possible inputs. And
the one thing people in America don't want to know is this is the way you have to do it. I mean, everything, you want to get pushback, particularly in Maine. It's local control, local whatever.
Yes.
So what you want to do is get the best practices, and I've been part of the Teacher of the Year program for Maine for years, and some of the Teacher of the Years are just so brilliant in how they approach things that I guess there's a lot of ways of teaching every subject. I really do like the example because it's helpful for me, who's not a math teacher, to understand the concept.
Right. And I think that there's a lot to be said for taking pieces that work and integrating them where we do. The Scarborough is the town I can think of that's closest to here that's adopted a Singaporean approach to teaching that. There are other towns and schools throughout Maine who use it or have been influenced by it, and starting to influence even the national standards, the Common Core standards have Singaporean representations
Yeah.
written into them. It's all blending.
Mhm. Yep.
Thank you, though. Thank you for your comments.
Yep.
Anyone else have something to ask or say?
Okay, well, true confessions, I fell in the dark hole trying to do the algebra piece.
Uh-huh.
Um, and yet I kind of knew where I had to be, but I knew I did not have that visual representation to do it. And
Uh-huh.
as I supervised our students in the field at the middle school, again, I could see where they're going to the procedural piece and kind of getting into trouble because they don't have the visual representation. And yet I see the teachers trying to bring that back in.
Oh, yeah.
That I want to see the procedure, but I also want to see a visual representation or an explanation, as you and Peggy were talking, what is your rationale for your solution?
Yeah.
The second piece that I found so interesting, Kevin, was the books. Our textbooks do have a lot of razzle dazzle to try and get students' attention that have nothing to do with the math. So they kind of bombard the student with all this visual stuff that doesn't really help them solve the problem.
Yeah.
And so the pages you showed were so math oriented and targeted and simplistic that they really can look on the page for support to solve a problem.
Mm-hmm. It's so interesting. You notice that it's those textbooks. That's what really surprised me when I first looked at them. I thought it was like C, Dick, and Jane. It's just simple. How could Singapore be #1 in the world and have these very simple math textbooks? But actually, they're really quite profound mathematically. Mathematicians tend to love them. The textbooks that you saw, it's interesting. There is never an adult pictured in a Singaporean math textbook. No adults. And that's because they really are trying to promote children talking to each other, helping each other solve problems, having math be a more communal activity. But they keep it very, very simple. And US textbooks look like magazines. They look like People magazine. Sometimes it's hard to even find where the math is. But it's, I just find all of these differences to be fascinating. Yeah.
Well, I think the criticism of a lot of education is that the companies that make the tests or the companies that make the textbooks are kind of ruling the roost as opposed to the educators.
Right.
That I've heard many times.
Yeah. The Ministry of Education in Singapore makes the scope and sequence, makes, they generate the entire curriculum. Then they go to a textbook publisher and bid it out. Who will make this to our precise indications? Who will build this for us instead of the other way around? We could go on and on about our criticism of math education, but these techniques, I spend a lot of my summers now. This is my season where I'm starting to spend a lot of my summers talking with teachers and training teachers in these methodologies. And what happens is that for many of the elementary teachers, they start to understand the mathematics that they're teaching for the first time. The light bulbs are going off because they're saying, wow, I never thought of it this way. And that empowers them to makes them excited about teaching math again. But these ideas aren't new. This has been this push for conceptual understanding in U.S. math education has been true for 60 years. This isn't something new, but these techniques are particularly interesting and engaging. So,
Kevin, can you comment on mental math and just the relationship that outcome would have to this? I've always thought of it as what you want to teach or the tool you want to possess so that you can quickly be productive. Yes. And earlier you can get to that, the better you will be. Can you comment about the relationship?
Yes, and be careful because I'll go off for quite a long time about this topic. So I'll try and stay brief about it. But here's the idea. I used to think, like you did, Joanne, that you teach kids mental arithmetic, you teach them to memorize those facts, and you teach them strategies so that When you're in the supermarket, you can quickly estimate or figure out what, what you need. You're at the car dealership or whatever. You need to have some mental arithmetic in your toolbox for daily life. But there are plenty of math educators in the US and other places who say, wait, no, it's not all that important now because everyone's walking around with a phone. And so you have a calculator practically strapped to your hip. So you don't really need all this anymore. And I disagree. And here's why. Through teaching children strategies for taking numbers apart and then putting them together again to make your math work easier, teaching them that is actually developing what's called number sense. Their ability to be very, very flexible with how they compute with numbers and the relative magnitudes of numbers. So that number sense is what makes a child in an elementary school classroom feel confident. That makes them feel like math class is a place where I could play around. I've got 2 or 3 different ways I could take this problem apart and try it out. And so I like math class because it's kind of fun. It's a puzzle I can solve. These are children that usually have strong number sense. And Singaporeans are pretty clear about the fact that they believe that number sense is not this kind of 6th or 7th sense that you are born with or not. They believe it gets built. Number sense gets built, and how you build it is through doing lots of practice with mental math strategies. And this is not, this is not only Singaporeans believe this, but that's now why I think it's very important, and it should be part of a good math curriculum, because it gives you a sense of number that gives you confidence and excitement about working with mathematical ideas that carries through the grades. If you come up in elementary school and you're feeling confident with whole numbers and working with them, that's going to carry through into tougher, more challenging courses later on. And I really do believe that this is an essential part of good math education. Does that help with your question?
It does. And earlier taught, the better. Is that correct? Or
We start in kindergarten for sure.
Yeah, for sure. Yeah.
Yeah.
Kevin, what was the or what is the reaction of our undergraduate students to, as you work with them in the math methods class? Are they arriving with a kind of a procedural mantra as they enter your class? Is it more balanced, are you finding over time?
Good question. For all of the work and effort that's been put into this conceptual understanding idea in math education, you would think that students who recently graduated from that system would be fluent in it, but that is not what I find. And I know you taught math courses too, Janice. They are, I find them to be much more focused on procedural fluency. That's what they have developed an understanding of or a efficiency with. And so for many of them, when I'm teaching them these methods, the light bulbs are going off. They didn't understand elementary mathematics as well as they do now because they've seen these kinds of things. And this is true for me too. This is why I became a math educator, because I was in a similar place, and it was not until graduate school that I started to realize the depths sort of elementary mathematics. And once you master those, it's fun. So I'm seeing what you're talking about in undergraduates as well. But these are the folks that I teach want to be teachers. So they're really excited to see things like this. Now they've got something they can hold on to, and they can see how this could make a difference for kids. And that's really fun. These are wonderful questions. I really appreciate your time here.
I have to run off to take somebody to the airport, so I got to scoot. But it's very interesting, and thank you very much. I actually did an evaluation of St. Joseph College for Education, the education program, on 2 occasions when I've been on the state board, and it's a good program. A lot of, as with most small colleges, a lot of connectivity between the teachers and the students and sharing. So I'm much more so than at the bigger university. So anyway, I've got to scoot, but thank you all very much for inviting me.
Thank you. Thank you, Peter.
Yeah.
Take care.
Dr. Mahoney, I have a question.
Yeah, who's that?
This is Deirdre Podgorski.
Hi,
And
Dee.
hi, I'm an alumni,
Okay.
so I just happened onto your. I'm interested in mathematics, a math minor, but I can't even do like add and subtract when somebody's trying to ask me how much I should be putting tip onto a bill. But so I just thought, oh well, maybe he'll teach me something new so I can relearn how to do it. And I'm fascinated. I actually am thinking of it in terms of, and here's my question, I'm thinking of it in terms of adult learning. And I'm asking the question of you, do you think that there are some parts of this that could assist like adults to understand critical thinking skills? My organization is lacking critical thinking skills at the deepest sense. And so I want to somehow instill that and begin to, I run projects all the time. And so I want to figure out how can I begin to get people to become creative and think outside the box and try to analyze a problem and understand that that problem may have more roots that go out that impact other things. And therefore, oh, maybe I should think about how to spread, you know what I mean?
Yep.
Those kinds of change management concepts.
Yeah.
How do you think that these things could be used in that kind of context?
Well, that's a humdinger of a question. I love it. Thank you very much. And it stretches me far afield. And I would say that what I've noticed in terms of sort of group dynamics, creativity, team building, a really, really great way to approach this, at least part of the one ingredient in the stew, could be some mathematical group problem solving. When you get a bunch of people together and give them a math problem that doesn't have an obvious pathway, really, really simple solution pathway where you can just take out your calculator and get the answer. You get people collaborating and listening to each other in new ways. It takes a while, it takes practice, it takes time. But I've seen it happen with lots of groups of children who, when repeatedly asked to tackle problems together and given responsibility for solving a problem as a team, tend to really connect with each other after a while and respect each other in new and different ways, because it often takes some kind of outside the box thinking to tackle this kind of problem. That's my best answer for your question. I think there's value in this, but it's, the problems to be solved don't always have to be mathematical. There could be other ways to tackle it too. But thank you. Yeah. Glad you attended. I appreciate that. 4 o'clock on a beautiful day, and you're here talking about math. Way to go. Oh, Joanne, I think you're muted.
Sorry, thanks. There looks like there's a question. I'm a middle school math teacher who uses Singapore method. And thank you for the great presentation. So it's to everyone, I guess, from Ashland. I don't know if you saw that.
Great.
Great.
There are real people out there using it.
Yeah,
I'm
awesome.
not making this up.
Well, it's really great that you were able to do this and give this presentation, Kevin. And thank you so much for the time and the effort and all the good work that you do at St. Joseph's College. It's wonderful that you received that distinguished award, and we're really proud of you and excited for what the education department is doing. So it's really, really great.
It was a great honor. It really was a great honor to me. So I'm so excited to have won that award. I really am.
Wow. Thank you. So this concludes our front row for this session. The next session is going to be June 1st, and former Professor Michael Conley is going to be presenting a little bit about his book. His new book is Murky Overhead. So you're going to hear about that. It's really talks about the Eastern Promenade and the whole Portland heritage and the immigrants that have been fleeing to that area for quite some time. He's a distinguished author, also writing a little bit about some of the people on Mudjoy Hill, and you'll enjoy his story that he's going to share, entitled Murky Overhead. So if you can join us the same time, June 1 at 4 p.m., that would be wonderful. In the meantime, everyone have a really great evening, and thank you so much, Kevin, for all your hard work and for tonight's presentation. Great to see everybody. Have a good night.
Have a
Thank
good, bye-bye.
you. Bye-bye.